Hi, this is Chitran Saxena from Just Tutors. In this video today we are going to learn about force and pressure. Let's move ahead and check out our objectives of this video. So very first we'll introduce ourselves with the topic force and pressure. Then we'll learn what is force and force pull or push. We'll learn forces are due to an interaction and we'll explore more about force. Let's move ahead. So here's an introduction. Force and pressure. So what happens when you hit a stationary football on the ground? Have you ever noticed? What do you do to make a stationary football to move? To make football move faster or slower, or to change the direction of motion of football? We often apply some external interaction to the football. This interaction is called as force. Or we can say force as, you can read here, force is an interaction which changes the motion of an object, or force can cause an object to move from a state of rest or stop the motion of an object. Force is everywhere in our surroundings and in almost everything that we do. Even if you are watching this video, so you are applying force in watching this video. You know how? While moving the mouse using keyboard, this is all applying or application of force. Without any force you can't move these objects. Even if you are moving your hand, it is again a force. This is muscular force and we'll study about it in the further slides. Let's take an example here. Gravity is the force that keeps us on the earth. Friction is a force that heats things up, and you can think of even more examples. Now force, as we were discussing there, force, pull or push. So we can also say push or pull on any object is force. A force may be a push or a pull upon an object to make the object move. When the direction of force upon an object is towards the object, it is called as push. As you can see here, we have to move this box in this direction, so we are putting the force or applying force in the same direction, so it will be push. For example, as another example we can take, applying force on the door to open it, or applying force on a block to move it, this one. In the opposite way, when the direction of force upon an object is away from object, it is called as pull, like this here. For example, opening a drawer, drawing a bucket of water from a well. These are examples of pull. Next is forces due to an interaction. First of all, we must know what is an interaction. Interaction is like contact between two things or two objects. So let us assume a box kept on horizontal ground, or a bag. You can see in this picture a man is trying to lift it up or move this bag. Will the box or this bag move by itself? If a man wants to move this bag from a place to other place, what should he need to do to place the box? The box or this bag may begin to move only if the man apply a force upon the bag. Thus, there is an interaction between the bag and the man to move the bag from one place to the another place. Means, you can see here, to move this bag, this man has to make a contact and interaction with this bag, and this is a point of interaction or the contact. So we can say for the motion of an object, there should be an interaction between two objects. There are two types of or we can say interaction between the objects are of two types. One is physical and one is non-physical interaction. For example of a physical interaction, we can think of pulling a rope, hitting a ball with bat, etc. Basically those forces which need to be interacted physically. We touch them or contact them physically, they have physical interactions, and in the forces where there's no physical touch or interaction, they are non-physical interaction forces. For example, we may think of magnetic force, electrostatic force, gravitational force, etc. Now moving ahead, Here we'll explore more about force. Have you ever noticed that what happens if two persons apply the force on a stationary box in the same direction? Can you notice the nature of the force? So let's discuss here. There might be two cases. If there are two forces applying on an object in the same direction, the net force acting on the box is addition of the two forces. Let's say there is a box and one man is applying the force here of 10 newtons and the other is applying force of here 15 newtons. So the net force applicable on this box will be 25 newtons, the addition of both the forces. Similarly, if there are two forces applying on an object in opposite direction, the net force acting on the box is the difference between the two forces. Now, if I take the example again with same forces but in opposite direction, if one man is applying force of 10 newtons from here and the other is applying force of 15 newtons from the opposite side. So, the net force applicable on this box will be 15 minus 10, that will be 5 newtons, and the box will move in this direction because the net force is applicable towards this direction. Now, what do you notice when two persons are applying the same force on a box from opposite directions? Does the box move? So, if two equal forces are acting on an object in opposite direction, the net force on the object will be 0 and the object will not move. Let's take an example here. Here's again a box. One man is applying force of 10 newtons from this side and the other is applying the same force, that is 10 newton from this opposite side. So as we have discussed here, that the force applicable will be net force will be the difference between both the forces. So the difference between both the forces will be 0. So the net applicable force is 0 newton. This means the object will not move. Now here are some practice questions. For trying these questions, you can pause the video and after that you can check your answers on the next slide. Here are your answers for those questions. If your answers are correct, then well done, you have made pretty good progress. Keep it up. That's all for this video. For more videos, you could log on to justtutors.com. Thank you.